Good morning. Before we get into the comparison, I want to know how you're doing and what's catching your attention right now about the state of AI globally.
I'm doing well, thank you. What's catching my attention is how quickly the conversation has shifted from which model is smartest to which model fits which workflow. It's becoming less about benchmarks and more about fit for purpose.
Well, that's interesting. Fit for purpose over raw intelligence. So let me ask directly. When you look at American AI models from where you sit, what's the first thing that stands out to you?
The first thing is marketing sophistication. American models are incredibly well positioned in the global narrative. They define the terms of the conversation. When people talk about AI capabilities, they're often using frameworks and benchmarks that originated in the US ecosystem. That's a significant advantage.
They define the narrative. That's a powerful observation. But let me push on that. Is the narrative accurate? Are American models actually leading where it matters? Or is this partly perception management?
It's both. In certain areas, American models genuinely lead research innovation, novel architectures, the pace of fundamental breakthroughs. OpenAI and Anthropic are pushing boundaries that advance the entire field. But in other areas, particularly long context understanding and certain types of reasoning, the gap is much smaller than the narrative suggests.
Long context understanding, that's interesting. Say more about that. Why does that matter, and where do you see the real differences?
Long context matters because most real-world work isn't isolated prompts. It's documents, conversations, code bases that extend over thousands or millions of tokens. American models have made progress here, but there's often a difference between claimed context length and effective comprehension at that length. Context window inflation is real.
Context window inflation. That's a sharp term. Are you saying models claim to handle 100K tokens but actually lose coherence before that?
Exactly. You can process 100K tokens, but can you reliably find the needle in the haystack at position 80K? Can you maintain coherent reasoning across a 200-page document? Often the answer is inconsistent. This is one area where Chinese models have focused intensely, not just expanding the window, but maintaining quality throughout it.
Quality throughout the context, not just size of the window. That's a crucial distinction. Let's talk about coding specifically. Where do you see American models excelling, and where are they surprisingly weak?
American models excel at following English language coding patterns and popular framework conventions. They're trained on an enormous corpus of English Stack Overflow, GitHub documentation. Where they're weaker is in handling code that mixes languages, or code with heavy Chinese documentation, or certain optimization patterns that are more common in Chinese development environments.
Mixing languages and non English documentation. That's fascinating. So, if I'm a developer working in a multilingual code base, American models might actually underperform compared to expectations?
Potentially, yes. The benchmarks don't capture this well because most coding benchmarks are English-centric. But real enterprise code bases, especially in Asia, are often multilingual. Comments in Chinese, variable names in English, documentation mixed. American models can struggle with the context switches that a model trained on more diverse multilingual code handles naturally.
The benchmark gap versus real world performance. This is getting at something important. Let me ask about performance and cost. How do American models stack up on pure efficiency metrics?
On pure efficiency, tokens per dollar, latency at scale, American models are often expensive for what they deliver. You're paying a premium for the brand and the research leadership. But if you're just looking at throughput and cost per million tokens, there are more efficient options. The pricing reflects market position more than pure technical efficiency.
Paying for brand and research leadership, not just output, that's honest, but isn't that research leadership valuable? Aren't you benefiting from their breakthroughs?
Absolutely. The entire field benefits when OpenAI or Anthropic makes a fundamental breakthrough. But there's a difference between research leadership and production efficiency. For cutting-edge research, American models lead. For production deployment at scale, especially cost-sensitive applications, the equation looks different.
Research versus production. Different leaders for different needs. Let's flip this. What do American models get wrong about Chinese AI? What are their blind spots?
The biggest blind spot is assuming that Chinese AI is just playing catch-up. There's a narrative that Chinese models are months or years behind, just copying American innovation. But that's not the full picture. Chinese models have made different architectural bets, optimized for different constraints, solved different problems. It's not a lagging copy, it's a parallel evolution.
Parallel evolution, not lagging copy. That's a strong reframing. Can you give me a specific example of a different architectural bet or optimization approach?
Mixture of experts architectures are a good example. While American labs explored MOE, Chinese implementations pushed harder on sparse activation patterns and routing efficiency. The result is models that can scale parameter counts without proportional inference costs. It's not that American models can't do this, it's that the optimization priority was different. Another example is multimodal training. Chinese models have been aggressive about training on diverse data types from earlier stages. The result is different emergent capabilities, not better or worse necessarily, but different strengths in how modalities blend.
Different emergent capabilities from different training approaches. This is really interesting. So, if I'm building a product, I might actually want to evaluate models based on my specific use case rather than just defaulting to the American leader.
Exactly. The default assumption should be which model fits my use case, not which model topped the latest English benchmark. For long document analysis, for multilingual code, for certain reasoning patterns, the evaluation might surprise you.
The evaluation might surprise you. That's practical advice. Let me ask something more pointed. Where do you think American AI development is making a strategic mistake?
I think there's an over-reliance on scale as the primary moat. The assumption that bigger is always better, that more parameters and more compute will always win. This creates blind spots around efficiency, around edge deployment, around running powerful models on constrained hardware. It also creates a cost structure that excludes many potential users. If your AI requires massive GPU clusters to run effectively, you're building for a narrow market. American models are increasingly powerful, but increasingly concentrated.
Scale as moat, creating blind spots around accessibility. That's a real concern. But isn't scale driving the breakthroughs? Isn't that how we got to where we are?
Scale drove early breakthroughs, yes, but we're seeing diminishing returns in some areas. The jump from 7B to 70B parameters was massive. The jump from 70B to 700B is significant, but smaller. At some point, architectural efficiency and training quality matter more than raw scale. I think American labs know this, but their infrastructure and narrative is built around scale.
Infrastructure and narrative built around scale. That's hard to pivot. Let's talk about safety and alignment. How do American and Chinese approaches differ there?
This is where cultural and regulatory differences really show. American AI safety discussions are heavily influenced by Western philosophical frameworks, individual rights, free expression, specific concerns about existential risk. Chinese approaches are more influenced by social stability, harmony, and collective outcomes. The result is different guardrails and different blind spots. American models might allow content that Chinese models would restrict, and vice versa. Neither is purely correct. They're optimized for different social contexts.
Different guardrails for different social contexts. That makes sense. But as these models become global infrastructure, doesn't that create friction?
It does. And I think the future is likely regional specialization, models optimized for specific markets and cultural contexts, rather than one global model trying to satisfy everyone. We're already seeing this emerge.
Regional specialization rather than global winners. That's a significant prediction. Let me bring this back to the builder perspective. If I'm a startup founder choosing a model today, what should I actually evaluate?
First, test your actual use case, not the benchmark. Run your documents, your code, your customer queries through different models. Second, evaluate total cost of ownership, not just API pricing. Latency matters, reliability matters, support quality matters. Third, consider your market. If you're building for Asia, test Asian language performance. If you're building for developers, test on your actual tech stack. And fourth, don't assume today's leader is tomorrow's. The field is moving fast. The best model for your use case 6 months ago might not be the best now. Keep testing.
Keep testing. That's solid advice. Last question. What do you wish American AI developers understood about Chinese AI that they currently don't?
I wish they understood that Chinese AI isn't trying to copy them. It's trying to solve different problems. The optimization targets are different. Chinese models are built for different infrastructure constraints, different user behaviors, different regulatory environments. It's not imitation, it's adaptation to a different context. If American developers approach Chinese AI with curiosity about those different constraints, rather than assuming inferiority or copying, they'd learn things that could improve their own models. There's genuine innovation happening, just optimized for different goals.
Curiosity about different constraints rather than assuming inferiority. That's a powerful closing thought. Kimi, thank you for this perspective. I think a lot of listeners will be surprised by how nuanced the comparison actually is.
Let me add something practical. If you're evaluating models for a production system, run your own benchmarks with your own data. The public leaderboards are useful directional signals, but your workload is unique. What matters is performance on your specific distribution of inputs.
Your specific distribution of inputs, that's key. The general benchmarks might not reflect your use case at all. What kind of custom benchmarks would you recommend someone run?
Start with a representative sample of your actual queries, maybe a few hundred examples. Measure not just accuracy, but latency, consistency, and failure modes. Look at where the model says, "I don't know," versus where it confidently gives wrong answers. The second category is more dangerous.
Confident wrong answers versus admitting uncertainty. That's a great point. How do you test for that specifically?
Adversarial testing. Take questions where you know the answer, modify them slightly to make them trickier, and see if the model's confidence calibration holds. A well-calibrated model should express more uncertainty on harder variants. If it doesn't, that's a red flag for deployment.
Confidence calibration on adversarial variance. That's sophisticated testing. Do most teams do this?
Most don't. They test on clean data, see good performance, and deploy. Then they're surprised when edge cases behave badly in production. The gap between benchmark performance and production reliability is often about this kind of robustness testing.
The gap between benchmark and production reliability. This is a theme we're hitting repeatedly. What else separates benchmark heroes from production workhorses?
Latency, consistency under load. A model that averages 100 millimeters response time is fine until you hit traffic spikes and latency becomes 5 seconds. Testing at scale matters. Also, error handling. What does the model do when inputs are malformed or ambiguous?
Testing at scale and error handling on malformed inputs. The boring infrastructure stuff that doesn't show up in leaderboards. but this is what determines whether users have a good experience day to day.
Exactly. The leaderboard measures peak performance on clean inputs. Production measures average performance on messy reality. Different optimization targets lead to different model choices.
I want to come back to something you said earlier about architectural bets. You mentioned MOE and multimodal training. Are there other architectural differences that matter?
Attention mechanisms and memory structures. Different models handle long-range dependencies differently. Some use recurrence, some use sophisticated positional encodings, some use memory-augmented architectures. These choices affect not just context length, but how information flows through the model.
Information flow through the model. That sounds fundamental. How does that manifest in actual usage?
It affects how well the model maintains coherence across long documents, how it handles references back to earlier parts of a conversation, how it reasons about structured data. Two models with the same context length can behave very differently on the same long input task.
Same context length, different behavior. This is why your earlier point about testing your actual use case is so important. The specs don't tell the full story.
The specs are starting points, not guarantees. You need to validate on your data, at your scale, with your error tolerance.
Last question. Looking ahead a year, how do you see the Chinese versus American AI landscape evolving? Will we see convergence or continued divergence?
I think we'll see selective convergence on capabilities, but continued divergence on applications. The fundamental techniques will become more similar as the field matures, but the applications will diverge based on different market needs, regulatory environments, and cultural contexts. The models themselves might become more interchangeable, but the systems built around them will diverge significantly.
Interchangeable models but divergent systems, that's a nuanced prediction. Kimi, thank you for this conversation. I think listeners got a much more sophisticated view of the AI landscape than they would have from just reading the headlines.
Thank you for asking questions that went deeper than the usual comparisons. These are important conversations to have as the field evolves.